Here is the user's guide for the transient sub-transient model of a synchronous generator. The transient model is implemented in a three-phase star-grounded source model. As an example, I draft a very simple test circuit consisting of a three-phase source and a three-phase breaker. One side of the breaker connects to the source, the other side is short-circuited by a wire across the breaker terminal on the right side. The start point of the generator is grounded. Double-click the source. For the transient model, I will enter the voltage in the transient input form, not here. Click on the Add Input tick box and press the transient button. Enter all the required data in the transient input form, none of them should be zero. The voltage is the nominal phase-to-phase RMS value in volts. With the nominal MVA rating of the generator, the nominal current is calculated automatically. The impedance data require per unit values. The transient time constant is typically in the order of a couple of 100 milliseconds, the sub-transient a couple of 10 milliseconds. The last time constant is the DC time constant of the short circuit current. Return to the main entry form. You see that the voltage has been taken over and has been converted to the usual peak phase to ground value. I intend to run the simulation for 400 milliseconds. The short circuit shall be interrupted after 300 milliseconds. Don't forget to tick the Open After Current Zero box, otherwise you will get a mess with the recovery voltage across the breaker. I want to see the breaker trace only, therefore I remove the voltage trace at the source. I input the simulation time and the number of steps. 4000 should be enough. I run the simulation and quickly I get the result. Here you see the green is the short circuit current, 3 phases, and after current interruption of the breaker I see the voltage recovery across the breaker in blue. I have prepared a simple system with 3 generators. Each one of the generators has transient and sub-transient model, and the generators are connected to the system by means of transformers and by means of short power lines. And here I have a longer power line segment with a short circuit at the end of the line. Let's now run this simulation as well. Oops, one of the lines is too short. I have too few steps, therefore I have to increase the number of steps and rerun the simulation. It is a little bit less responsive because I have much more steps, and here you see the result. Again, voltage before short circuit, then short circuit current, and then recovery voltage across the breaker.